Today is a little bit different. Yesterday, I went through a lot of topics and covered different parts of about data science, and also we talked a little bit about some ideas about machine learning. But today we are getting into one very specific module called Pandas, which is kind of like a programmable Excel, and it's very, very powerful. And I'm using the Pandas on a daily basis. And if you are, new to Python, new to data science on the programming side, Pandas probably is the first package you want to get yourself familiar with. So today we'll move very slowly. I know you all have your computers here, and so for those of you already online, I know you should have a computer with you. So I'll go through this slowly with you all and get everyone into Pandas. If you are familiar with Pandas, feel free to leave because today is very, very, I would say low level, probably not low, not the right word. Probably it's entry level introduction to Pandas. And after getting used to Pandas, you'll not get away from it. It's just so useful, so powerful. Whenever I get a file, the first thing I want to do, I just open it with Pandas. That's what I'll do. So with that, let's get started. I think we have people. So Pandas itself is a very highly optimized. When I say very, because this package has been there for a while, and people from everywhere who have been contributed to Pandas has been figured out ways to utilize it for many different projects and being helping the community to optimize the package. The APIs, when I say APIs, means application programming interface, more or less like the functional interface and also the interface, the library interface, and you call and use Pandas for doing things, in your Python programming language or some other languages. If you want to have a wrapper around it, you can use it with some other languages. And the APIs are very, very user-friendly. If you're new to Python, there's like a golden standard. If the package is written in a very Python way, it will be widely adopted by the community and it will be used a lot. One of the issues that TensorFlow that you will learn about later on is that TensorFlow, the first version TensorFlow, is completely different from the way how most Python programming is written, and the way how you use TensorFlow is dramatically different. That's why it got easily beaten by PyTorch, which is another deep learning neural network framework developed by Meta. And the second version, Google learned the lesson in a hard way and started modifying their interface and started adopting this Python-like interface. When I say Python-like interface, it's more or less if you're new to Python, it's interpretable language. Every line of code you put in there, you get results feedback right away. And it's an object-oriented programming language. That means when you write your code, you don't do this like structured programming language. You do it step by step, and in most cases, you do it as an object. You more or less define a table for the entry for your data first, and then give a table name. Anytime when you're playing with any object, here I'm talking about table. The table itself is an object. So in the table, you have columns and rows. And when you're writing an object-oriented program, you deal with all the rows and columns, and the entity itself is an object. So all the entries and output from that object will be all the operations needed for you to implement in that particular packet for you to deal with those objects. So Pandas is one of these programming library that you can use to play with tables and all kind of tables. Just like many other modules in Python, any modules at the level of this popular, they are guaranteed to provide all the basic 4 categories of functionalities. If you're a programmer, there's 4 basic types are CRUD, CRUD. Let's make it easy to remember. I don't put it here, but I just want to make sure you all have some rough idea about how the functions and functionalities inside the Pandas got organized. So C means create. If you have a software to manage a table, you need to have a functions inside this package to provide creation functionality. That's create, right? When you're programming C or Python or directly using Python, you should be able to manage all the files. There must be a module for you to create files, create some other objects. So creation is very important. So Pandas can create tables. Okay. Second one is R. it's meaning read. So for any modules, Python modules or any other modules, if you want to update the information, you have to read the information first from some written format or some other format in the file format or any pre-given standardized format. So that's a read. The third one, U, I say CRUD, CRUD, right? U is updating. So sometimes just reading the information from the object or the table itself doesn't mean much. You have to do something about it. Then when the action when you do things is more or less like doing update. That's what U is referring to. So last one is D, delete. So you have a creation, you have delete. So you close the whole story. You can create it, you can delete it, you can modify it, you can read it, that's all. So Pandas provide almost everything for a regular table or irregular table. And as long as you can read in, you can do whatever you want. It's just anything you want with the table. If you cannot find a function to do it, it might be very likely that you'll find it in a newer version, because not just you, hundreds, thousands, I would probably say millions of users of Pandas worldwide. So it's possible that everyone might be facing some similar problems. They'll be reporting to the community. Things got to fix right away. So that's the beauty of the open source software. Of course, if a commercial software is maintained by a small company, it's kind of hard to maintain all the changes or implement all the features. But the big companies that do have similar features, but you need to pay a fee, and it's kind of hard to find the testers for the new features, like all these softwares, open source software. So again, it has all the capabilities. CRUD, it's 4 categories. There are many other things, and if you want to use the Pandas with some other machine learning models in the future, and we'll talk about those, it's very easy to build up a pipeline for Pandas to do some pre-processing, and then your data will be cleaner, and you send it to the model training process, and then after your results is done, you can send it to Pandas again for post-processing. So Pandas can handle pre-processing, post-processing, and also visualization, all together. All the rest could be handled by another machine learning model that we'll be talking about, either scikit-learn, or machine learning module, either scikit-learn or TensorFlow or PyTorch, that we'll also cover in the next several days. So that's like opening remark I want to make for Pandas, just let you know how good it is, how wonderful it is. So of course, when I'm already talking about something so wonderful, you may always ask, well, what's the catch? What's the catch there? So Pandas is not designed for handling unstructured data sets. We all actually have one day to cover those tabular data sets like graphs or those social networks, but that's not something that Pandas is good at. So Pandas is good at handling tabular data. When you have columns and rows and anything you can put in that format, Pandas can handle them nicely. So tabular data could be stored in the SQL table. Some of you are familiar. How many of you are familiar with SQL database? Some, not so many, but more or less like you create a database, and then you create multiple tables. These tables could be linked to each other through some common shared columns. We call these keys, right? Then you have a relational database. Database connect to database, kind of like you have when you go into Walmart to buy posters. They are putting together with all the axes. You can just flip around. All the keys, kind of like those axes, you can use to check all the tables, right? It's kind of similar idea. Then you can do query and other things to get everything connected. That's why it's called a relational database. Mostly, that's what the standard database is about. SQL is a language for you to query the information from your table and upload it in any format you want. Could be in XML, could be CSV, could be JSON, could be other format. The most commonly used small database, and some of you probably already have it on your phone, it's called SQLite. As far as I know, it's probably one of the most popular file-based database. So it's nothing more than just a single file. You can save it, and you don't need to know what's inside. It's just like in a binary format, and it's in a certain format. SQLite, which is a database, it's written in C. You can download and compile it anywhere. It's very portable. I'm sorry, I'm probably getting too far away from the Pandas, but SQLite is another very nice tool if you want to get started with some development work. SQL could be the SQLite, could be the default library you can use and for storing your data in a queryable interface. It's a very nice small packet for database. Any other thing like Excel spreadsheet. So Pandas has this extra plugin you can install, can directly open Excel files. Of course, your Excel should be in a tabular format. If you have a lot of merged cells, it's very easy to confuse Pandas. And you need to probably get into the table, when you read into a Pandas data frames, you need to probably do some cleaning. But as long as your table is, it's not formatted to make it readable for human beings. Sometimes when we make tables readable to human beings, we are damaging the internal, structure. Make it harder for Pandas to understand which column is what. If you have merged cells, how can you explain to Pandas which particular column is referring to if you have, some mixed headers for different columns, right? So that's a tricky part when you're handling table. I know I work with folks from vet school, and sometimes you guys bring me some tables, and it's very nice, very nicely formatted. You can read it. Anyone without any background in your field can read the table, but it's not designed for Pandas or this kind of processing. So that's why sometimes when you share data or work on the data with this kind of tools, it's better to keep the data as raw as possible, actually, in most cases. Because in the raw format, it's nothing more than just columns and rows, and that's it. You don't have merged cells, you have no extra comments here and there, and that's make it very easy to process. And Pandas is also good at processing time series data set. I mentioned Pandas, or probably mentioned it yesterday or not, it doesn't matter, we'll get into that. Pandas has a very special way to label put an index there. So Pandas has, we'll get into that, but I'll just stop here. Otherwise, I'll spend too much time repeating what I'm saying. So it's very good at handling time sequence data. When I work on digital twin projects, I probably talked about that yesterday. We do get a lot of sensor data coming as a time series. It's nothing more than just key value pairs. The key is a timestamp. Value is a value, whatever you're detecting. I could have a weather station here measuring temperature in this room, every 5 seconds. So every 5 seconds, I get a timestamp, and then which is just time, and then I have the value for the temperature. So I can get a sequence of that. So Pandas can store this in a very structured manner, and it can convert your time format in a format that can not only easily readable for your plot figures, but also for analysis. You can do operations for time. You can find a data time. It also consider the time sequence itself also has a built-in dictionary for you to check the. You don't need to do that. It automatically checks the like leap years and figure out exactly which day it is, etc. So it's already built in. So you don't need to worry about it when you're trying to do some plotting and do some analysis and very detailed analysis. If you needed to worry about leap years, that's actually a headache for some of the tools. You might not have this kind of feature. Also, any matrix could be written in a format like a tabular data set. It's just like for any matrix, you don't need to specify which header it has, but give me a matrix, I easily map that into a tabular format. Kind of like an image. Give me an image, it's nothing more than a 2D matrix to me, right? It's just map it to them. For example, for this snapshot of this screen here, every pixel is just contains 3 values, RGB values, right? Sometimes it contains 4 if you have opacity from different format. But it's just like layers of 2D information. And every pixel could be put into a tabular format, and then you can study columns and rows separately. So make it straightforward for you to analyze on images in that perspective. So there are many other formats of observational data, statistical data sets, and you'll figure out, you'll learn how versatile these Pandas tools are for you to handle different data sets, and you'll like it. So Pandas, there are 2 basic structures. The basic structures are very, very simple. It's not designed to handle hyperdimensional, data sets that you are dealing with. It's simply just a series, which is just key pair of values. Give me a times, or could it be time, could it be something else, then you can store the value, this key pair, a key value pair. And the second one is a data frame. It's just a table. It's just a fancy name called table. The name comes from R. I know many of you are good at R. Data frame, you can find a similar concept or definition in R. Actually the concept here is actually borrowed from R. So whatever you learn from R will not be vested. So if you want to switch to Pandas, whatever you learn is actually still applicable in the definition of the Pandas data frame. So it's just a 2D data, and it has a mutable, size mutable tabular structure, and you can do heterogeneous types of columns. Could be a string, could be floating points, could be Boolean values, could be, you can even store complicated structures there. And that's something, it's like an advanced feature if you are dealing with complicated data structure. But in general, it's probably easy to just store, a single type of data so that you can easily process them with the Pandas default functionalities. So this is like a series in Pandas. It has an index and a value. Index itself is more or less like a name for the particular cell to save the value. So make it easy for you to refer to a particular value just by giving the index for Pandas to refer to the value. Okay, more or less like this, like a key, this like a value. You have a key, open the door, you get the value stored in your memory address. Kind of like analogy, something analogy like that. To define this is just 1D. I'm talking about just a series in Pandas. We're not talking about data frame yet. Only 2 data structures, very easy, and don't even need to remember. You'll remember this anyway after today's presentation. A series is just one-dimensional labeled array, can hold any data type. But one thing is different from dictionary. Dictionary it's very special data type. You don't see dictionary in some low-level languages like C or C++ or Java. There's no such data type like dictionary. Python and some other like Perl, Python, and some other high-level programming languages that do contain dictionary. Make it easy for you to do queries, do some quick searching. But again, it's not so efficient. And because you need to first, when you try to search a value, you need to first search the key, and according to the key, you search the value, right? If you already know the index for the particular array, just go directly to the memory address and pull the data out. But in many, many cases, you don't know the particular address. For example, you want to find some value. You don't know which row it is, but you know that the key, corresponding key is B. And with this kind of key value pair, you can grab the value quickly. But if you just index the base, if simply based on 0, 1, 2, 3, all the indices, it's kind of hard for you to do any kind of quick search. So that's the advantage of the programming languages like Python and Perl to deal with. Perl is another scripting language that was really, really popular many years ago. People use that to process files, do text processing. I use Perl a lot myself as a part of a research project. But after Python started picking up, Perl starting, the user base for the Perl is starting declining, and Python started picking up. But in many ways, Perl still has a pretty big user data, user base, especially in the government and also the national labs. Actually, HPRC, High Performance Research Computing Center, they still offer Perl courses for some of the special user groups. They are the group doing all the hard work, hardcore numerical computational stuff with all the code maintained, developed starting from the 50s, 60s. They still use those kind of tools to keep the code running. So not everyone is in favor of Python, or it's still just kind of so hard to rewrite the code without assuming any potential mistakes, right? So that's why they still keep the old code base and maintaining the software relevant to those. To create a series, the easiest way just to provide is a list. Provide a list of numbers, and then you can have a separate index array corresponding to it. So they could have a matching or non-matching numbers, but it will automatically do the matching. The first index here will be referred to the first list you're providing as a series. So when you create a series, you need to provide an index as a list and a value as a list. So Pandas will do the automatic matching. If you don't have any value provided here, only have 3 values in the list. The second, this 2 will be left open, and just D and E will be referring to now values in your series. So another quick way to create a series, Pandas series, is to initialize a Pandas series with a dictionary. So this is a definition of a Python dictionary. It's a standard Python dictionary, nothing fancy. You have a key, you have a value. Given this, Pandas will turn this into a series. And just like that, nothing fancier. And also, if you have a index here, if you have provide only one value, it's kind of similar. The same value will be copied all the way as a scalar, unless if it's a list with a 5 and all the other empty, or just with a 5 as a list, it will only match 5 to the first element. If it's just a scalar like this, it will just assign 5 to all the values. So there are multiple ways to initialize a list. A Pandas series, but this shouldn't be that hard to understand what's going on. It's very intuitive. So data frame is a little bit different because it's a 2D, and then you need to provide not only the index, but also the columns. So columns more like a header in your table, and you provide the columns, column 1, 2. This is just should be strings representing the name of the columns, and the index representing the name of the row. Now, it's kind of like you have a coordinate system you set up. You just tell me your C and say, for example, D, index D, and also column C3. You can uniquely determine this one value at this cell, right? Kind of like a coordinate system you're setting up to help you to identify all the things. With this power, you can take the subset of this index and subset of this column. You can do subsetting of the whole table because it's relatively easy for you to identify corresponding blocks relevant to particular columns and particular rows. You can do many other manipulation of the table itself. So this is the official definition from Pandas. It says 2-dimensional size mutable. It can easily change the size, okay, and a potentially heterogeneous tabular data structure with a labeled axis, rows, and columns. So it will be this axis is 0 and axis 1. That's the default setting. Don't ask me why it's 0 and 1 in this way. That's just the way how it goes. It's pretty much like the dictionary inside this Pandas container. There are multiple ways to define that as well. You can also, for example, this one, it's kind of like a dictionary, but your key here refer to the column, particular column, and a value refer to the values of your column. So you have 1, 2, 2 rows. The first row is 1, the second row is 2. So when you do this, you're creating a 2-column, 2-row data frame. That's a table you're creating. So this the way how you initialize your data frame. Okay. But in general, people usually don't do initialization this way because you always load your data from a file in most cases when you do analysis. Sometimes, occasionally, you probably want to manually change some values here and there. You need to play with individual element cells. Right? So here, this is a cheat sheet for Pandas. It gives you some basic operations, and you can try out yourself. But after you try this, it's not so many functions. Actually, as I mentioned, if you understand that there's 4 types of operations, for each type, there are only a couple of functions you use mostly. For read, you mostly learn how to load the CSV files, Excel files, and some other format. For a read, create, you simply create a Pandas data frame using loading function. That's more or less like reading and save that into a data frame, and you got it. You got the data frame defined. And updating other things, you do queries, and usually, the most commonly used updating is mostly about checking the null values, checking the not a number values, and empty values, and filling those. And a delete is just one function. It's just delete. That's the function you use to remove the particular column or particular. You can drop. You can drop and delete those. Okay, so today we'll be focused on exploratory data analysis. Again, we'll reserve this for the next several days. We already talked about some summary. You can do some visualization, which is straightforward. But what does exploration mean here when you talk about data. So I showed you one example previously in the very first very first example. But before we get started, so I want you all to click this open in Clamp button and open this Exploratory. I believe this file should be readable. Can you confirm you can open it? Okay, should be okay. So we'll go very, very slow today, not like yesterday. I like flying through a lot of topics, but today we'll go very slow. I know many of you are not familiar with Python, not to mention Pandas. So this is a notebook that you can click run and run all here to, but today we'll go step by step. We don't want to run all. We want to see how things are going all by ourselves. So you can move your cursor. You can see there is a running button here to the left. You can click it. If you're more comfortable with mouse clicking, it's definitely the way to go. Again, just you need to trust me. That's basically what is volume message says. So another way to run a cell is to use a Shift Enter. It will run your current cell and move to the next one. Shift Enter. That's what I usually do. It's much more efficient. You put your hands there, just keep doing this, and you'll get your current cell executed. I think there are also some. Oh yeah, here. If you want to see how all the other, it doesn't say any Shift. Oh yeah, Control Enter is to run the focus cell. Control Enter will run the focus cell without moving to the next one. Shift Enter will run the current and move to the next one. I believe this is Alter Enter. We'll run the current and create a new command cell to the next one. Okay. Shift Enter, Control Enter, and Alter Enter. You can try it yourself. Sometimes when you type a code, then you do an Alter Enter, and then you get a new empty cell. You can type in your, whatever you want to type. Say print, whatever. We don't have anything to print here. So if you want to drop this particular cell, this is called a one cell. There's a delete button here. This is awesome. You can drop this. If you accidentally dropped some code you wanted to go, you can just go back. There's on delete cell. There's Control MZ or Control Z. It should be working. So this essentially is like editable notebook, and it has almost all the features needed for a desktop application. It's a very, even though it's a web-based interface, but it's give you very good control of everything. Okay, so we are loading Pandas, and the PD here is just alias or Pandas. Most of people, if you are reading documentations and codes online, PD is the most commonly used alias for Pandas. PD, Pandas, NumPy, NP. That's what everyone's using. I don't know. I mean, that's probably someone started. Then they started creating all the alias for the lengthy modules. So the next time we use it, it will be very convenient. PRT is a pretty commonly used alias for pyplot, which is for plotting and other things. This is actually a Jupyter Notebook thing. Back then it's called IPython Notebook. That's when you want to do the inline plotting. Because Matplotlib can plot things, but usually plot save it to an internal memory block somewhere or save it to the file. It will not show up automatically to the front end. You can see it. So that's like for some older version of Jupyter Notebooks or Jupyter Lab. You have to declare that I want to show the plots in line, and then it will show everything automatically and refresh the page so that you can get the plotted figure loaded. But I believe for the latest version, this is not needed. I just keep it there just for backward compatibility kind of thing. But it doesn't matter. You can just run it. It doesn't.
I would like to add something before they get started. So if you click on the file on the top, and you can save a copy.
You can save a copy in Drive, and it will save automatically to your home drive. Probably it's a home directory. That's like a separate copy. That's yours. And you can use it later on. I don't know. You probably can find if you go to Google Drive, it should be popping up on your home. If you click home, it should be the first one showing up. Yes, this is the one I just saved. It's a copy. It's not an original one. Right. So by default, it'll be saved to the Colab notebooks. That's your directory. That's where it's saved. So for all the Jupyter notebooks, could be saved this way. But if you're familiar with the GitHub, you can save this a copy in your GitHub. You can keep updating this, and the GitHub will treat it more or less like a text file, and it can also directly show the Jupyter notebooks directly on the website, make it very convenient for you to see the differences, and also for version control. If you make some changes you want to save and want to share with others, this definitely is the way to go. And also it's free, and everyone can have an account there. So that's a GitHub. Okay, now I'm running. Let me just close this version. This is, I don't need this one. I can run directly here. This is the one I'm just running. So as I mentioned, we'll start with object creation. This is the actual example I showed in the slide. And if you run it, it will save this everything into S. Make this bigger. So this is a list inside of Python. A list is just like an array, but this array contains all kind of data type. Could it be none? Could it be string? Could it be Boolean value? Could be anything. So given this list and this function series or take this series is more or less like a constructor or initialization function you call to initialize a Pandas series. So what this statement says is I'll create a series using this as an input and save that into S. Then when you run S, this is what your time series. Okay. So the default data type here, data type is a D type is data type, means it's 8 byte double precision, which give you a precision up to 10 to minus 13, 14, I forgot, 13, which are already sufficient for most of the numerical applications. So it's a default data type when you have numerical values saved. So we have our first not time series, it's just a first series. Okay. Sure. Yes. So this actually is a special, let's say, if you're doing any numerical stuff, none is a very special thing. It's actually first defined in Fortran. If you are familiar with Fortran, it's a formula translation language. It's started as a very first high-level program language. So none is defined as not a number. It's a pretty general definition. When 1 divided by 0, you don't get some credits. It will be marked as not a number. It will be, cannot be represented with a number. That's not a number. That's a none. If you get any memory, sometime in Fortran, if you get a memory leak and get some trying to address to get value from a memory that are not allocated to your program, you'll get a none as well, because you are extracting some information you not have access to. The system will return a none to you. So in Fortran, everything not a number is treated as not a number. But in C++ and C, there is other definition like now. Now is like empty memory address that when you cannot get a number, it will give you either not a number, none, or now. In Python, none is not a well-defined term. So actually, it's defined inside NumPy. NumPy is mostly focused on numerical crunching, and it's a numerical library for dealing with all the calculations, dealing with large-scale numerical calculations. And none is defined as a part of a special, I'll call this a special symbol inside the NumPy. And that's why I put a none here. It's just not a number. Anything, could it be 1 divided by 0? Could it be, any other things? But this is just representing a non-numerical value, but it doesn't contain any meaning. It's just like an exception, more or less like that. If you have an empty value here, it could be now, N-U-L-L, which is different. Now in Python, it's representing nothing. It's just nothing. But none here is a special representation for not a number character. The reason, okay, I need to get back to the reason why this none is important, okay? It's also, you can also trace all the way back to Fortran, because the first language I learned is Fortran 77, so I know the history of all this. When you get any nonce, and whenever some other function is calling this none, it will create a none. So if you define a none like this, you can write some extra programs or libraries help you to catch where this first time when the none happens. It's very, very helpful for debugging. If you sometimes accidentally you get some NaN, you don't know where it is. You can write a NaN counter to find where this NaN happens at the very beginning in your very complicated code. And when you run your code, it's not during the debugging coding process. It's just when you run your code, some NaN got created because some values got running crazy, and numerically you get NaN. And it's mostly very useful for debugging and other things. So there is a question here. Please, do you want to unmute yourself and ask directly?
Yes, I'm sorry. I'm trying to figure out, are these modules supposed to be showing up in our Google Drive?
Not a module. It's actually this Jupyter Notebook will be showing on your Google Drive. Can you see my screen?
Yes, but I'm not seeing in my Google Drive the the 10 minutes.
You needed to save a copy in Drive if you do this.
No, I mean, I don't even see the actual file.
Oh, it's in the slide. If you click to open in Colab.
Got it. Oh, I see what you're saying. Sorry. Okay.
Yeah. Sure, no problem. See, we are running very slowly, but just bear with me, and if you know how powerful this whole thing is for data analysis, you'll like it anyway. So next, we are doing something a little bit different. We create a set of dates, and these are actually the time. The period here is 6. I just want to create, starting with this one, I create 6 periodical dates based on my starting point. This is just one extra feature. This is the data range itself is providing. If you're familiar with the range is a Python function for you to create a list of variables, and you can use for iteration and other things. That range is doing something similar. You can specify the starting date and specify how many iterations, how many periods you want. It will create 6 dates for you like this. And the format, it's pretty flexible, but again, it's only work with a year, month, and day. I tried month, day, and a year. It doesn't work. So I'm pretty sure the programmer here for this particular function is from Europe or Asia. If it's American programmer, it'll put a year, a month, day, and a year. If you put a 0, 1 here, it doesn't work, and it gives you an error message. So because it's a date range, that's a function name already. So if I didn't get into the time range yet, but you can probably search up. I never use that time range, but there will be similar functions providing the time as well. So now this might not seem very interesting. Also, you can see actually if you look at the output, it's already providing the frequency here. Actually, D here representing days. So it's give you the timestamp for the day, and the type is a data time 64, which means actually, even though you see these dates, but actually there is some external time giving you the 0000 for the particular day starting point. So it's showing just the day time for the data type showing up here. Okay, it looks trivial, but now let's see what we can do with these dates. Sorry. So we can generate some random number. It's random generating a random matrix, 6 rows and 4 columns. And the index here, because we just generate 6 dates, right? Let's just use this dates as my index. That's my row index. And the column is simply just a list of this ABCD, which is just ABCD. And you'll see what I'm talking about. So this is what I just generated. I have ABCD 4 columns, and then I have 6 rows, each row with an index with a date. Okay. Now I think I should have some plotting examples a bit later, but let's just take what it is, and then we'll get into that. Also, Python or not Python, Google Exploratory especially in the latest version. Previous older versions don't have this. It has suggested plots, which is very useful for you to do some interactive plotting with all these tools. Where is it? So it's trying to plot, I think it's a suggested plot. I'm not sure. Well, it's cool, but it seems not, not so useful and useful now. You can also see the table directly with a nice format, and which is nothing more than what I just showed there. It just makes things look better. Let me just remove this one. Okay, so we have a table created. We have a dates and the columns, and we have more or less like a time sequence measurements. This is already usable for me as, for example, for developing this digital twins. My table is lots more than this. I have time here. It's not just daily. Could be have different hours every 5 seconds, 5 minutes for my measurements data from all the sensors. These are different sensors: A, B, C, D, E, F, G. I could have 100 sensors for the residential house. I showed you all probably. I'm not sure if we showed you all last time, but you can have many sensors, and collect it as every time step. You get multiple sensor data coming, and you can start collecting data like that. And it's already non-trivial data you can play with. So that's assuming that's a table is created, and then we'll get into some analysis later on. But let's just keep it here, assuming we have a table. You can create tables with different formats. This is another data frame I'm talking about. Data frame is nothing more than a table. So this could be a table you can create with A here, since it's just a scalar. It's just copy everything to the next row. If you look at this A here, it's just a number. If you put it as a number, assuming all the rows should have the same number. If you put a list, then it's a different, you can try it yourself if you put a list there. Then B here is just timestamp. It's also the same, but which doesn't matter. I just want to show you what it works. And then C is a Pandas series. Pandas series is nothing more than a column. So it'll forget about the index, because the index will be overlapping with your current index of data frame. It will save all your current values into your current column. And the D is a NumPy array with a 3 times 4. Basically, it's 4 columns, 4 rows, and each one has a value 3 here. That's a NumPy array. Don't worry about the index, the syntax for the NumPy, because NumPy is a different monster. It's have a lot of very interesting index manipulation stuff, and you might need to spend some time to understand how the NumPy syntax is working. But this one is more or less to define a NumPy array with a data type integer 32. It's only 4 byte, not very long integer. You can only hold up to 2 to 32 numbers. It's like 4 billion numbers. That's up to the maximum 4 billion. If you have 64, you can have even higher. And that's basically how you create a table with different data types. And but again, creation, as I mentioned, is not so essential for most of the data scientists, because we don't create the data myself. But in some cases, you want to create some data just for testing purpose. So now I want to check all the data types. So what I type is just df2 is a data frame I just defined, and then have a data type. I show all the data type for all the columns, because by default we assume every column have the same data type. So when you do analysis, one column is the same data type. You can usually write a very generic tool to handle them. If it's a completely different data type, there's no way you can handle them in a more systematic manner. We want to guarantee every column has the same data type. So there are some other attributes. Actually, on Google Exploratory, this tab might not be working. Usually, when you don't know what you want to type in here, you put the dot and wait. It will show you all the functions you might need, you could use, because that's all the building functions inherited from that Pandas data frame, and also the first several here. Actually, you can see these are just representing different columns. If I type in df2a, it will just show you the first column. And actually, the recommended syntax for using the column data is like this. That's what Pandas community is recommending. So df2.a and df2 square square bracket A. Actually, it's the same thing. But here, make sure you need to put single quote, double quotes, or single quotes here, so that you can refer to the particular column. Okay. You need to get your hands dirty, and while I'm typing, you also can try out. The reason why this is not commonly recommended because, for example, this one. This is just a transpose of the if you look at the df2, that's you have columns and rows. All the A, B, C, D, E, F, those are the columns, right? But if you do the transpose, it will give you the columns and rows will be just transpose around the diagonal axis. So the reason why this is not recommended because it's very likely you could be confusing with the function calls and other things. That's why the community is recommending using this as a square brackets to call different columns. A, for example, you can also have a list inside this. For example, I have capital case A, B. Okay. Now, if you look at it, what I'm putting inside here is actually the Python list. So it tells df2 that this data frame, I want to pick these two columns. It will show you two columns inside of this. So you can simply doing the filtering. Say, I want to, if you are familiar with a SQL language, when you select everything from, you can select a particular column from this table, select A from the table df2, you get what you want. But here it's more or less like a select statement in your SQL database language. So I'm selecting A and B, and I can save it to a df3 or df5, whatever. Just make it larger number so that I don't need to confuse about that. So then you can show the df22, df44 will be storing this data, and you can start your processing. So after your query, you can save it to a new variable, and it will save all the files, all the data you queried from the previous statement. Okay, that's the creation and some visual, some manipulation tools. So to view consider you already have the data frame defined. A head here will show you the first 5. By default, it's 5. You can show only 3 here. It will show you the head is just the top 3 entries of your table. If you have a very big table, it's definitely useful. Another useful one is just show the tail. This shows the last 3 rows for your table here. Right? And index will show you all the indices. Columns show you all the columns. These are already coming directly as a function call. And you have A, B, C, D as your columns. Now, if you just want to extract a value, this will show you just a value as a NumPy array. And this can directly fit into your model training and other things. Of course, you needed to understand which column is what, which row is what. But when you're feeding the data into a machine learning pipeline, this is the only thing you need to fit in there. That, your machine learning model training doesn't need to know what A, B, C, Ds are. That's just for your own reference. They just needed to know the numerical values. And this is actually the metrics that you want to send over to the next step for model training. So describe is taking all the numerical values and calculate the corresponding statistics, and for you to do some further analysis. But just look at the numbers, it doesn't make sense. Sometimes you need a plotting to do some visualization. And the Pandas also provide a very quick way to do the visualization for you. So we'll get into that a little bit later. I already mentioned you can do the transpose. It's simply just transpose data, make it easy for you. And also you can do this, say, for example, describe. So it will first describe, output this matrix, and then I can do the transpose. So because the output of this statement is a data frame itself, and then it can continually build up. You can build a pretty lengthy statement with all the dot operations. Every dot operation is trying to call a built-in function, and depending on the output of this particular operation, you can keep doing that. If it's all the output is a data frame, you can keep doing all the operations and query and other stuff. Makes this the statement more, probably shorter. You don't need to have multiple statements. It's one statement will do the work for you. Okay, so given a Pandas data frame, the first thing you do, given a table, you definitely want to do sorting frequently, once in a while. Here, you can do sort based on the index, and the axis here could be columns, could be rows. Now we are sorting along the columns. If you look at the column here, instead of A, B, C, D, it's going to D, C, B, A, right? If you sort along rows, rows. So you'll keep your columns untouched, but you'll switch the orders about rows. Then you can also sort, not index, you can sort value by particular column. So remember, all this could be done just by writing a statement like this, and all different operations could be run in a batch mode, one by one. You don't need to go to your Excel to click the button to do all this. For any data type, after you get this notebook written, you can reuse it for processing the future data files, and all this could be done just by running this whole script. Okay, I think we are almost an hour now. See, I told you, when I want to slow down, we can be very, very slow, and we are still just 1/3 of this given notebook. But again, it's a very good practice for you to see what all these tools can do for you, and think about what you have done before manually, and try to think about how this can help you to speed up your data analysis process. Right? You get your data imported from some raw data format, and the Pandas can help you to read the data and do something. So we still have some time. Let's continue. So as I mentioned, this is a way to select one particular column, a recommended way, square brackets. Okay, and then of course there's also other ways to do it. This will be more or less like a Python way of getting the selected members from your list. If you know your index, for example, this here is selecting all the rows from index 0 up to 3 rows. So 0, 1, 2. 3 is not included. It's starting from 0, count all the way to 3. So 0, 1, 2, but count 3 and not until 3. So you get the first 3 rows selected. And if you have the time, you can select this based on the time range, which is a very powerful way. If you don't know the particular index, you just want to do the query for a given time, that's your statement you can put in. You don't worry about which row you are in. Assuming you have millions of rows, you don't know which row you are in, right? This will be very, very efficient for you to do a quick query for the time. And for 3, it'll give you just 2 rows. So assuming you want to just study a particular year or particular time period of the data set you have, this can create a small, you don't just manually select it, you can, but this could be easily done with, with a separate, it can save it in different data frame. This file, this could be saved into a separate file. So df234, I think you can do save. No, I'm sorry, Pandas save. It's a PD save. Well, it should be df. I'm sorry, it should be at later. I forgot it was particular. It should be on the df side. I'll getting back into that when you want to save the particular data. So you can save this particular chunk of df into a separate file, and we can get it. Save. I'm sorry, it's write. It's not save. It's write. We'll get into that a bit later. So you can select the index by labels. You can from 0, and then you can locate the particular date. Again, this will require some practice. I'm not saying this is something very intuitive to myself. So I start using this function. This locate is trying to locate the particular row, and based on the input, that if you output this date, this will give you a timestamp. More or less like you use this, you're using this timestamp as a query to find a corresponding value. Actually, given this query, Pandas will give you one row here. It looks like a column, but actually it's just one row of data. It's saved into a series, one-dimensional series. Of course, you can pick up arbitrary. This is a Python syntax, means ending row. You don't give the lower end and the upper end. It's just a column with empty and boundaries, empty ranges. I'm sorry, it's empty boundaries. Then it's more or less like selecting. You are telling Pandas to select all the rows for you, and then you want only these two columns. So that's what you get. So think about it. You can more or less like draw a bounding box inside of your table. You get the starting row and ending row, starting column and ending column. You can get the small subset of data extracted out for your analysis. That's basically what this one is. You can specify the starting point and ending point like this one. You can just draw more or less like a cutting that big table into a cut a small rectangle from your big table, right? So that's probably the ultimate way how you can deal with your data. When you want to extract a certain part of data, you can do it. So that's the power you have with all the programming interface here. Okay, so there's, this can also reduce dimension because now you are reading only one row, and with multiple columns, you can reduce that into one dimension, which is just a series. And if you give me a very specific column, very specific row, I can extract a value for you. This will return just a value from that particular cell in your table. Okay. So that's more or less like you can select a small subset of the table and an individual value of the table by giving me more or less like coordinate. Give me x and y. This is x. That's y. I can get the value out to you. It's nothing more than that. It's like a coordinate. Sometimes if you only know the index, this is a location, it's the same as location, but now we're using the index for locating of the data. I'm looking for the actually the fourth row because it's a 3. Python is always starting from 0, index starting from 0, 0, 1, 2, 3. So this will return the fourth row, even though its index is 3. This is your series. Give you because one row is it's just one series, it's just one dimensional. Data frame is 2-dimensional, but series itself, when you pull out one row is a series. It will be using your column names as your index for this series. So this is another way of extracting the small part of your table, but here this I representing index, more like index-based location. Locate, index-based locating, I'm sorry. So you can extract starting from the 3rd row and the 0th column, and then you get 2 columns and 2 rows, and you get this subset of that table out. Okay, that's all about this one. You can play with this. You can create a table and you can play with it. It's exactly the same way of doing that. Okay, int is just indexed int more or less that you're providing the index. That's exactly the same way how you identify a value from a NumPy 2-dimensional array. You give me x and y index, I can find the corresponding value saved at that cell. Okay, that's all about locating a particular part or particular cell inside your table. And that's actually very important for you to really want to ping into individual number, individual row, individual columns to deal with your table, right? Deal with the data you want to analyze. And that saves some time for you to do the mouse clicking and drag all the columns and copy them, save it to a different file. You can do that just with a command line and just straightforward. Now, this is the conditional statement. I think there is a question here. Oh, what's the logic behind having 0 rows? Well, if you have 0 rows, you have an empty data frame. It's just a now table. What do you mean rather starting? Oh, 0 means because all the Python index starting from 0. It's just an index. It's not the number. Like 0 here is not a quantity. It's just an index. Because all the Python starting with 0, Python indices starting from 0. Okay, good. I'm sorry, yes, it's kind of interesting. If you're familiar with many other languages, C started from 0, C++ 0, Java 0, Python 0, MATLAB 1, Fortran, Fortran 0, 1, 0. What else is 1? R is 1. It's just different. The different community have different habits. It's just, I don't know. Whoever first designed this language, they have the say about if I want to have index 0, index 1. It's just the different habits. Yeah, definitely. It's just if you get in. Oh, Julian started with 0. It's just like a Python. 1 or 0. I'm sorry, Julian started from 1. I was actually teaching a Julian course a couple of years ago. Now I've completely forgotten. So it's just get so many languages in your mind, you sometimes get confused. Now you have. So this this is a very powerful way for you to pick a certain group or do some filtering. It's just doing a filtering of the data you have. Here, my condition is I want to pick all the data I have when the column A is greater than 0. Okay. When you do this with R, you can easily do this with R, I assume. But this Pandas index, the syntax is very clean. It's actually this is providing a Boolean value, like a Boolean index, a Boolean series actually. DFA greater than 1 itself, this statement itself will be resulting in a Boolean series. True, false, depending on if it's greater than, particular column row is greater than 0, less than 0. It will create a Boolean series. And the Boolean series will be working as a filter to filter all this DF out, which is quite impressive. I mean, whoever designed this syntax is very, very nice. And actually, to me, it's very intuitive. I only want to output my DF whenever DFA is greater than 0. How clean could it be? I don't think you can get it even cleaner than this statement. So now this one is more aggressive. It's trying to compare all the DF values, everything, all the cells, if it's greater than 0. If greater than 0, output it. And then you get all the NaN values here. Oh, sorry, why it's NaN value here? Let's check. It's 1, 1. Oh, we have, let's see, 1, 2 here because NaN at the bottom is negative. So it's just turn all the negative ones into NaN values. That's what it does. I would say it's probably simply because it doesn't have any values, so you just simply put a NaN there. The standard Python symbol could be null, NULL, but I think if it's treated as numerical values, it's probably just NaN, not a number here. Because you don't have any number showing up, but you want to show this row or show this column, you just show you NaN as a default value when it's not greater than 0. Okay, so that's a easy way to do the filtering. Just filter out all the negative values from your table, just with one statement like this. Again, you can save this to a new data frame. You can start processing that table as a new table. That's how you do some quick cleaning and filtering of the table you are dealing with. So copy, use an equal sign is another thing, and you can do a copy, and copy will do a deep copy of the current data frame into another data frame. If you save this df e, if you insert another call e, and then you want to, let's see, do df. But df won't be modified. The reason is that df, this df2 is a hard copy of this one. So basically, it's not using the same pointer pointing to the same table. It's just it creates a so-called deep copy. You have 2 copies. Usually, this is not recommended because that means you double your memory. But in some cases, you won't do that. Like in this case, you create a different copy, and then when you modify this copy, nothing will be changed into your current data frame. So you still have 4 columns, but for this df2, you can have 5 columns. This is how you create a new columns. Just give a name for the column. You can call this, let's call this F. You can then create a new column. And whenever you get a new column, you create it. This is a quick way to do that. Now, this is another statement. So this is trying to get the column E from the df2 and try to tell if this value of column E, which is here, is either 1 or 2. I think that's what this one is. It's either 2 or 4. If the column E has a value which is either 2 or 4, it will output the row. That's what this one is trying to do here. So this actually output 2 columns. This is, again, is a filter. And this is trying to do the comparison of a string instead of number. Okay. Now, setting a column, it's relatively easy. This is simply just create a new Pandas series, and then you set that particular column equals to this series, and then you get that. And let me output that df. That's what S1 is, I think. I don't know, for some reason it's probably. And then set a value, because you know it's 9 here, and then I want to set a value to 0. So you identify the corresponding, this is that time, that's 0, and this is F. And then I'm not sure. I'm sorry, this is not F. Let me set this F. You bring it out again, you set that to 0. You can set the value directly by using this set, directly by setting the value there. It's the same. You can use this to locate the particular value, and you also use this to set the particular value. And that's the quickest way to set certain values at a certain point. So that's how you manipulate with different columns. Okay, different functions. So now let's create a copy of df2. Let me show you what df2 is. That's still the older table we're dealing with. But now this statement is trying to say, whenever I find df2 is greater than 0, let's change that into a negative value. Basically, you want to take absolute value of all the columns. Whenever it's greater than 0, whenever it's greater than 0, take a negative value. If it's negative, you don't touch it. Okay, so let's see what this one will give us. So if it's greater than 0, you change them into negative value. And negative value, it will not touch it. So it will change everything into negative value. Okay, and 0 is definitely, it's not greater than 0, so it will not touch it. Now, this is probably the most interesting part for many of you. You need to deal with the missing data files anyway. So let's first show this example. You have some missing data points, assuming we just created this column, this df1, which is simply we created just with non-values for E here. So these are 2 missing points. When you're reading this will be showing up in your table, and you'll see there's no values. When you measure this particular quantities, you don't have any values on these 2 days. If you want to drop any rows with which has missing values, this is a very brutal way to do it. It's just drop alien. How? This alien. It's just alien as long as you have, no matter which column, as long as you have one column of this particular row contains not a number value or empty value or no value or missing data. This will drop none, means drop not a number row. It will drop these 2 columns. So you have only 2 columns, or I'm sorry, 2 rows. You have these 2 rows left, right? That's the easiest way to handle all the nulls. But usually, if you only have like 20 data points, you don't want to drop any single line of your data. That's an issue with many researchers that don't want to drop any single value. So what do you do? How do you deal with this missing data? Simply just fill this value. The easiest way, you can just fill a given value. Now, how to set this value? That's again depending on your expertise, right? If you're familiar with data set, you know 5 it seems to be a reasonable value, and for this data, by taking the average of the particular column, and this column, the average of this column is 5. When you try to do some analysis, you don't add any biases because your mean value is not shifting. When you do some analysis, you're not adding extra biases to your analysis because the new value you're adding is just a mean value, right? That's a pretty common strategy for fitting the value. But of course, that means you're adding some other things. Probably you're definitely decreasing. If you're adding the mean value, you're decreasing the standard error. You're decreasing the variation because this value, if it's not a 5, could be something else. If it's not a mean value, you're adding some extra variance to your data. Then by setting this value to your mean value, you're actually decreasing the standard deviation. Does it make sense? So that's why sometimes you should be cautious. And this is a good way to cheat. I'm sorry, it's not a good way. It's like it's one way to cheat by filling those null values, missing values with your just mean value, and so that you can decrease your standard deviation and increase the value, what you call sigma to noise ratio. Right? That's basically what a lot of people are doing that. So that's a pretty common user practice. It doesn't mean that it's wrong. It's just like sometimes when the standard error is very important for your analysis, doing this will definitely make your results better. And it's not a common practice for. Yes.
Previous step, you dropped observation that were in.
Yes.
But the next step, filled in this observation, previous version.
Yes. Yeah.
Is it not a permanent thing?
That's a very good. I'm sorry. There's one extra argument here. If you don't put it on, this only drops and output it. It doesn't really change the data frame itself. Okay. No. If you save it as a DF whatever, no, I'm sorry. You save this to DF say 34. Let's save it. And then your DF 34 will be containing only 2 rows. Then you won't be able to drop it. You won't be able to do any filling because you don't have those. But when you're just doing this, it will not change. It just show you what it will look like. It's changes just in the view. It's not in the data frame itself. But there's a one here. I think it's called in place, right? In place equals say 2. That will change. If you do df1, we have this. So that will make this in place changing permanent in your current data frame. This is not a default one. Default is false. So that even you accidentally drops anything, it will not be dropped from your data frame. You still have that. But if you really want to do it, just you don't want to make extra copies, you just want to deal with the same data frame, you can use this in place too. And many other changes this is there almost in many functions. Whenever you want to make some changes, if you put it in plus 2, it automatically changes the current data frame's property, or some rules will be removed, some changes will be made internally inside of this particular data frame. Okay. Now we have a problem. We have to go back to regenerate this F1. That's fine. It's just here. It's a follow-up example when you're able to run without that. So now I'm just filling this missing value is 5. And then this one I'll try to tell. Oh, again, even this one is not permanent. It's just temporary filling. If you want to do in place, you'll do this in place. Okay, it's the same. So if you just look at the df1, if you look at df1 here, you still have 2 NAS here. This will try to ask to check if you have any NAS inside of your df1, and this will output the corresponding columns for you, or corresponding row and a column for you. You can easily see the output. Okay. So I think for most of the users here, when you're dealing with data, this is like, it's almost there for all the pre-processing. We haven't talked about loading the data yet, but it's almost trivial. To load the data, as long as data in a given format, it's just one function call away. That's not a big deal. The big deal is here, how to make sure that you are not filling the wrong values, and how to make sure that the way how you do it makes sense, right? Actually, statistically. So fortunately, when you're trying to do analysis in Pandas, if you want to do analysis, it will automatically skip all those missing values. So it will not count those values in your n for total number, because when you're doing that sampling, right, doing a statistics, this n here, this n here is not the total number of data you have, it's the total number of nan, it only counts the numerical values you have. So you're, even if you have nans in your columns, you won't be able to make any statistical mistakes because it already excluded those nan values for you. For example, here, A, B, C, D, F, I think the E columns have any nans, so you will not do any calculation for the E, because it's just doesn't make sense to include those nan values inside E to calculate E. It will automatically be nans. So this is doing the analysis along this is along column axis. I think it's the last sum operation on the other axis. It's just like this one is along the columns, another one is along the rows. For each row, you do some analysis. Okay, so now we have another example here doing some shift. This is the one Pandas we are creating, and you are shifting this 1, 2, 3, 5, and you are shifting this by 2 here. You have 1, 2, 3, 4, 5, 6 values, and when you shift it, you are shifting this along this. I'm sorry, just trying to understand this shift properly. So it's a shifting, more or less like shifting this also to the positive 2 positions. And instead of aligning your 1, 3, 5 with all the dates, it shifted your column. Sometimes this is not commonly used, but sometimes when you do notice some problem, for example, there is some shifting of your data set itself, you want to shift your data to properly matching this time. It's not commonly used, but sometimes you need to deal with that. Basically shifting your columns by how many rows and how many, mostly it's columns, how many rows you are shifting. This is substitute as with access index, and where as here is the one we just defined, and the corresponding it's substitute as with sorry, the access with substitute index. Now, which one is substitute? Sorry, this along index with. I forgot what this one is. 9, 9, and 1, 3, 5. Okay, 9, 9, 1, 3, 5. It's no, not substitute. I believe I confused this. It's the subtraction of the data frame with other element wise. Okay, so it's basically I'm sorry, this is subtraction, not the substitute. I confused it with another command. So it's trying to do the subtraction of the data frame by subtracting each column with this s. Since the first row of this is 9, whenever you're doing operation with 9, you'll get 9. So that's why the first 2 rows is always 9, because you're always subtracting existing data frame, the default data frame df with this one. Let me show you what df looks like, then you can. So you're subtracting each column with s. Whenever the none happens, you get none, because any operation with a none will produce none, which is a reasonable way of definition of what none is. So anyway, applying here is applying a certain function to your data frame. This apply is doing so-called element-wise application, not applying, element-wise mapping. So you'll take this function and run this function on every element. That's how you apply this function to this DF. Think about it, if you have a table and you want to multiply every element by 2, you can simply do multiplication. But if this variation is depending on some other values, this function could be a very complicated function, can change your columns and your values in your table accordingly. If you want to transform your data columns and rows, and you can do this, but this one is just applying this to the whole data frame. If you only do, say, A, it only takes this A and apply this to the A itself. So you can do in this application applying the functions to the data and element-wise. So this is the same apply, but you are using so-called a lambda function. So lambda function it's just a function. It's just like you don't need to define a name for the function. Given any input value, here is every cell inside of your data table. Every cell means every individual element inside your table. What you're trying to do is take your element, find the maximum value. I'm sorry, this is applying to the column, I think. Here, it's a maximum value of the column, subtracts the minimum value of the column. Not a column, it's a maximum value of this, maximum value of this column, which is, you look at this column, maximum value here is 2.74, minimum value, no, it's, for A, it's doing this application of X max. What's the default? It doesn't make sense here. It's an X value. It's get the X max and X min and trying to find basically the range. B here is 2 point. If you look at the minimum value along this A-axis, actually it's not 1.77. I think it's subtracting. F. It doesn't. I'm sorry. It's as a default. I'm just trying to figure out what's the default direction. It's trying to do this application. It's trying to, the default axis is 0. That's along the columns. So anyway, I'll figure this out myself. I didn't went through this example carefully. I believe I sorted that through, but it didn't make sense to me. If you get the maximum of this column A and subtract the minimum value, it should be 2.7. I'm not sure if anyone found out why it's like that. For F, its minimum value is not. No, did we drop any columns here? DF, okay, that's a DF we have. It's trying to get the corresponding X and maximum X. Okay, I'll figure it out and I'll get back to you next time. But this one is kind of confusing to me as well. So histogram, this is trying to do some analysis about collecting data points to figure out what, just do a counting about how many times this particular value appeared in your data set. It's just a histogram plotting. If you do the plotting of a histogram plot, you'll get the value count about how many times this particular value shows. this works well for integers and some other strings, as long as showing up in the same representation, more than one times. It'll keep counting how many times you're showing up. It's just show you the histogram. Also, it has some string method. If you're dealing with strings, this will be helpful. And you can turn everything into lowercase. This is just a string processing. It's utilizing the Python's string manipulation power. And also you can concatenate your data frame, kind of like merging two tables. This also is a tricky part, because sometimes when you're doing the merging, you want to make sure you have all the alignment figured out and which direction you're merging. Could be horizontal merging or vertical merging. And if horizontal merging, you want to make sure you have some number of rows. And the vertical merging, you want to make sure you have some number of columns. So but it can do all this for you automatically. And what are these pieces? Let's see. So this will take the some small part of the DF and part of DF3 third to this is probably third to sixth row. This way all the way after seventh row, and merge all of them together with concatenation. So this is what the PD does, is concatenate the data and output everything into the final format. So this is how you deal with merging and concatenation, which is the same one. Now join is a bit complicated, because you needed to find a corresponding row or corresponding key to join. When you join two tables, you need to have the one particular column that's shared by two tables, and then you can join them, and find the corresponding the key is a important for you to do this join properly. Consider now we have two data frames created, and one of them is left and one on the right. Let's just put them here. So if you want to join these two, depending on how you do it. So if you just join the left and the right on the keys, it will keep all the same row aligned with each other, but attaching the left value and right value, stacked up as a big table. I'm not sure if it's so you have the left value and right value. So it's trying to matching the corresponding row left value and right value based on the keys you have. But again, you could have multiple keys, and this will guarantee that all those groups in one key will be lined up properly with the left value and right value paired up. And then you can group them. Oh, well, this one example is a follow-up example. It's just trying to, if you have a table like this, if you want to group all the values in, based on the particular column, you can group them by column A, for example. Then all the values, like B values, will be merged together. It's like, because for the strings, when you put strings adding together, it's more or less like putting the string concatenation of the strings. So you end up with you have to do the sum. Sum here, more or less, like if you have a strings, if you do the sum of strings, 1 plus 3 plus 2 on the string operation is simply just link all the strings together. For the rest, you can just simply do the sum of the column C. If you get the same A value, column A value, you'll sum all the rest together. So that's how you do the compilation of the, or do the grouping of the table you have. That's pretty common used practice. If you are using Excel, you probably have been dealing with this yourself by finding the corresponding columns and put them together and do some operations. But this one can do it all together with one command line. First, by the grouping by, and then you can do the sum for based on the particular group. This one is trying to do A and B, and I think this is starting with
It's trying to group A and B and do the sum based on the corresponding columns. I think it keeps A the same, and then for different B's, if you have if you have multiple rows with the same A, but also with the same B, it will sum them up. It's just like it can have another layer of filtering in this process. So these are more advanced features, and you probably don't use this on a daily basis, but once in a while you may find this useful. Even for myself, I don't use this a lot, unless there's some special requirements for me to do this. Reshaping Pandas data frame, and let me show you this is the example. It's done to show what DF is. So this is my DF I just created with some random generated data frame, and I can pick the particular. This is the last four. I'm sorry. It's starting from first first 4 rows. I pick the first four rows, and then this stack will create a stacked format for me. So I can have individual, have a first, a second, a third. If you look at this one, I stack the A and B together, but A and B will be rearranged into my rows here. Okay, so again, this is also not commonly used features, but it's just usable for certain applications. When you have some readable data that might not be easily accessible by Pandas, this kind of tool will be helpful. If you have a unstack, that you can unstack the corresponding columns, and you can do one more unstacking. You can get, depending on which column you are unstacking, you can get to unstack them. It's also unstack corresponding columns here. Okay, so here is another example doing the pivoting tables. And if you are familiar with this concept, you might find this straightforward. So it's trying to do here, it's trying to find pick the corresponding value D, which is the value you're selecting, and then you find the corresponding index A and B for you to do the pivoting. And your pivoting focus out along the column C. So let's see, that's, where's the D? D, I'm sorry, this value, you're using the value D, and you pick the index and the column. Those are more like a two, like a subset of the table you're picking. You're picking the column A and index A and B in your values. I'm sorry, you just text A and B as your index. I'm sorry, it's based on your value you have in the B column. And then you create a pivoting by rearranging the data in the format you want. Okay. You don't do this for data analysis, but it's helpful for you to manipulate data in a certain format that you want them to be. For time series, you can create this is something I already mentioned. You can create a time series and do the resampling based on the frequency. Could be is a very, very descriptive, probably 10 minutes or 100 minutes. You probably here you can change hours maybe. 10 minutes, and I think hour. I think I don't have so many data points, right? Let's just keep it here. You can get that resampling of the data points you have, depending on how many data sets you have, or could it be 1 minute? And it will do the resampling for you. So this is completely relying on the timestamp you have, and how many data timestamp you have. It will also make it easy for you to deal with all this time sequence data. Resampling is a default operation for many time sequence data. And you can also change the time zone accordingly, which is sometimes when you do the time series analysis, this is important. Give you the time zone, corresponding time zone. If you choose UTC or UTC-5, there are many others. You can look at the localized data type. You can convert this to US Eastern and US Central, etc. So all these keywords could be looked up on Pandas documentation. And now I'll go through this quickly. And this is creating a data with a month. Frequency here is a month. Is creating a data range with a frequency which is a month and a period 5. So basically give you 5 months of data. And also it knows exactly 2012 is actually a leap year. So it's give you the last day of the month is 29, which is something pretty nice. And it will change this into periods. And you don't need to worry about the last day, but it just changes that into corresponding months you are dealing with. And also it changes timestamps. This will convert that into the first day. So sometimes you don't want to worry about the last day of the month. You just need to say, this is just a month's time, starting with the first day of the month. This could be easily converted. There are many other tools here about changing your time sequence for the data, but it's completely your, if you're creating data with the quarter of, say, November, it's always your choice. I think there are many other things. Some of them I don't use a lot myself, but it's just give you almost anything you need for manipulating with the data type, and making the time series analysis very, very straightforward using this tool here. And here you have this one is trying to do the Pandas included. This is probably pretty old. I mean, latest version is probably 2 point something. It's like a very early version. So Pandas can handle this categorical data that we talked about previously. When you're dealing with classification problems and clustering problems, you sometimes deal with categorical data, which is not numerical values. I'm sorry, this is the cell. But different categories. We try to analyze the grids and try to assign a value to them. And you can save those raw grids as the categorical data, and you can deal with them, process them later on. And this one, I think this probably this needs to be updated. And I think, do I save the cat? Okay. I need to update that notebook. It's just using some old data frame. So it's a type data frame. You don't need to call that extra .cat to set the category. Simply just call the set category to be working. So this will be useful for again, this is extra call, which was there, but got discarded in the newer version. I'm sorry, it's okay. It's not working for time series. It's okay. I'll fix this one later on. It's well. Next, move to the plotting tool. Assuming you have a time sequence data, you can create a time sequence data. It's simply you can plot it out, and your x-axis will be easily labeled by the Pandas plotting tool, with you without worrying about all the details here, which is pretty convenient when you have a lot of tools like that. This is trying to do the cumulative summary for the data you have. You get all the time from January to sometime later in. So you can get multiple columns directly plotted out. If you have, since you have 4 columns, it's automatically take your 4 column data and plot it out for you. It's just very straightforward for time sequence. So lastly, I think that's the important part. We still have time. You can save. I'm sorry, it's save. It's not a save. It's just 2 different formats. To DC, to CSV, or to Excel, to some other format. You can save your data into full .csv. If you click this file button on Google Collaboratory, you can say the file is saved here. So all the files, you can save it to your CSV file. You can download them, and you can click here to download them to your local file. You can open that and use Excel, which is very convenient. And then you can read from this file. If the file is already on your Driven notebook here, it's already here in this current directory, or you can upload a CSV file, and then you can read that file directly to your notebook, which is straightforward. This is the file we just created with about 1,000, it's 1,000 rows and 5 columns, right? And there's another very commonly used format called HDF5, which is the hierarchical data frame, which is mostly used for saving simulation data, very large-scale numerical data. It's very, very efficient for saving large-scale, numerical values. I'm not sure. This file is not saved here, but you can. I'm not sure if you can save this to. Let me see. It's Pandas. Right to. What is the 2? I'm sorry. HDF maybe. No. Okay. Just put the names there. Full H5. I think what's the extra comment? I think that's it. Let's give it a try. It's the lattice or HDF. I mean 2H5, I believe it's 2H5 maybe. I forgot the particular, what's the name? Someone can do a quick search. I think it's PD. It's not popping up. I need a, come on, it's 2. Okay, it's probably not installed. It's supporting 72-HDF5 will need some extra format, but it's not here. Pico is a very commonly used format. You can save this to Pico, and it makes the file size pretty small. I think a Pico file. And pass to file argument. One require position on file pass or buffer. I think DF. Okay, so this can directly save to Pico file. I think that's this one to H5. Okay, here we go. I'm sorry. There is. It's directly calling from data frame, not the H5. Never mind. Let's just use Pico. HDF5 is usually used for saving the weights. Let's use the Pico and also to Pico. CKLE. Okay. So let's forget about HDF5 because it's there's a pretty older version, and probably some other changes has been made in that HDF5 format, the reader plugin itself. Pico itself is a pretty powerful, very efficient binary format to save these files anyway. You can load them, you can read Pico, Pandas, read PI, Pico. I think you can save this to DF, another DF one. Now, if you just DF 233, it'll show up the data you just saved. Because it's a binary format, it's about 1/8 of the size and probably 1/8 of the speed. It's very, very efficient. If you look at the size here, if you look at the CSV file, I'm not sure if you can see the size. Probably no, you can download, you can compare. This one is much smaller than this one. And also, when you read it, it's much more efficient. So it's recommended, if you have pretty big data files, don't save it into CSV, save it to some other binary format. This one is about 40 kilobytes, right? This one, 85 kilobytes, because there is some overhead for this one. That's why it's not that small. But again, when you read it, when you have a pretty big file, ASCII file always the worst format you want to save. CSV is a ASCII file. It's saving everything into readable format. Excel requires this external module, which is called OpenPyXL. If you get after you get this one installed, you can save your file into Excel files, and then you can also read it from Excel files. And if you look at here, you get an Excel file created. What's the size? It's about 66 kilobytes. It's a binary format. You cannot read it directly with your editor, but it's pretty commonly usable by Excel itself. So we went through, again, the Pandas can read your files, load your files, save your files, change your files, reformat your files, reshape your files, fill in the missing data points. It can be used for post-processing, and pre-processing. This example, I think we still have time, 10 minutes. This is a very standard example. I use it many times, mainly because it's give you some impression about certain things, and sometimes it's standard. It's help you for remember things. That's why I pick this like very very specific case, because sometimes it's very useful. If you can link to the report here, it's actually they are collecting all the data from 1982 to until 2024 for all the mass shooting here in US, which is this is an updated version. The version I have is up to 2020. That's when I last updated the student. I'll probably update later on with a newer version of data I have. So with all that we learned from Pandas, okay, let's see what we can do. So this again, this is probably not necessary. This is also trying to detect if I'm running on Colab. If not, I'll load it up from a local repository. Otherwise, I'll just read it from loaded from the file I already provided. So all these are just trivial statement for me to check if it's running locally or run Google Laboratory. So you don't need this anyway. So after I loaded some data, this is the first 5. This simply just use head to show the first 5 rows. And here we go. It shows the date, case, where it happens, the summary, fatality, injured, total victims, location, etc. So, and it's up to that until 2024. And this info will output all the data. So actually, since the data already clean, you don't see any missing data points. All the cases have 118 elements entries here, which we have all the columns filled in. So it's good. We don't have any missing data to play with for this one, but you can try some others yourself. So these are roughly give you a mean value for example, fatalities. It's about 8 people died on average, and they have standard deviation about 8 people. So it's 8, either 0 or 16, at that range if you look at the values. And latitude, longitude, those are not really meaningful here. This mostly by location. Probably, some people might see it's meaningful. I don't know. So latitude, longitude, that's like a location where it happens. So if mean and average, since this is numerical values, Pandas will do that for us. But how meaningful they are, I don't know. It's just doing some analysis. So this shows a histogram about a fatality. For example, most of the cases, they have a less fatality ratio cases here, about 80 to 90, with less than 10 people died. But there are some extreme cases, like in this one, so more than 60 people died, total victims. Not so many cases, of course, but there were some cases, and majority of that has a lot of people injured. What's this? It's a longitude, latitude. This doesn't mean much. I think latitude is just spreading across the different locations along the longitude. This latitude is just the U.S. is spanning, I forgot it's from where to where, from west coast to east coast, right? That's basically what's the latitude. Longitude. No, longitude is from 0 to 90. But latitude is going from east coast to west coast. And what's this one? I think it doesn't show the label here. This is a year. How many? As you can see, the total incidents are happening. If it's it's getting more and more mass shooting cases happening in the recent years. And since you have a locations, longitude, latitude, there is another very powerful tool called Folium. I don't have time to go over that. If you're interested in, you can take this data you have just to try to show it up on Folium. Folium is able to do a very straightforward analysis. I think they have some started example. all you need to do is just install Folium, and then this map will be automatically corrected for you. Given the latitude and longitude, you can plot out the position directly using the GeoPandas, which is another Pandas-based module using geolocations, and you can do some geoanalysis. And this Folium provide a very nice way for you to use map services. This is using OpenStreetMap. You can also use a Google Map as a underlying services, and given any data point, given a location, latitude and longitude, you can plot it out on this. So I didn't get into the details because I think this might be more confusing than helpful for this first example. So I didn't create this plot, but it's a very useful way to analyze data if you have any location information. So next one I have is a wine data set. And actually, I found one data set about dogs. I know it's there's a data set about the intelligence of dogs, and I probably try to do something about that next time. But I didn't put that into this notebook. But we can look into that data set next time. So this is a wine data set. I'm not a wine drinker. I drink beers once in a while, but this data set gives you a very interesting measurements of different quality measurements for different wines. And so the final goal here is trying to use all this, the reason why this is interesting, because you can, based on the people's evaluation of the quality of a particular wine, you can see how all these different measurements are correlated. Okay. But again, we are not building a model today. This could be useful for the model we'll be building on Thursday or Wednesday, but not for today. Let's just look at the data here. So, I don't know what all this means. Some of this is a biochemical measurements for certain things inside of this wine. You have pH values. This is some number I know. There are some other alcohol, and which is the percentage, right? All this. So you can take a look at all the values, how they distribute. This already have different bins containing different range of value, and then they will count how many rows are falling into this particular bin, and you can have a histogram for all the data you're collecting. You can roughly see the distribution of the data for different measurements. This is a correlation. This is a very important value, that try to find the correlation between two columns pairwise, like what I showed you last time. If you look at the quality, okay, this is the quality that people give. It's a subjective, because you want some people to give you the evaluated quality. It's not something. I don't think you can have a quality. You can evaluate the quality of the wine purely based on some scientific methods. This, I believe, is pretty subjective. So you can give a score to a wine based on different tests. I think I'm not an expert, but someone can tell us a bit more about it. So if you look at all these numbers, some of them are pretty interesting. Like the quality itself is if you look at the maximum number here, it's somewhere here. The last one is not relevant, like the quality itself, but the alcohol percentage is actually it's very correlated, very strong correlated. If you have a higher, not very strong, but it's strong. If you have a higher alcohol percentage, you get high quality evaluation. I don't know, because they got drunk and give you a good number, right? So I'm not saying we are going to draw any conclusions from this, but it's just something interesting to look at, and how all this could be correlated with certain quantities you are looking at. And this plot is, anyone can take this and use this this function to draw. It doesn't really say which data set I'm dealing with. It's just very generic plotting tool. You can get this plot for any data you're dealing with, just by loading the data and just show it. This table give you a very good overview about all the corresponding correlation about all the data sets you may have. If you look at the pH value, and I look at this value here, pH value, and what's this? Acidity, I believe. A critic acid, I'm sorry, citric acid. I'm not expert on that, but it's negatively correlated. Not very strong, but actually it's pretty non-trivial negatively correlation between these two. So, but makes sense, right? Acid is the more acidity means probably the lower pH value. So it's not, it's definitely it should be relevant. So, and then you can look at some other values, probably, you know, to see if it really makes sense. Sometimes it doesn't, but in most cases, those values actually, this correlation doesn't make sense in many ways. So the next one, again, this is some variables I picked. You know, some values I picked. I'm trying to see how they could be correlated, how they show up. You know, how they're correlated to some extent. The hue here is more or less like a color. Color shows the quality. The darker the color here means the high quality. Lower the color is lower quality. But you know, I don't want to prove anything. I just want to show the data. You know, there's just different quality values for all the numbers I see, but they seem to be spreading around with different, you know, distribution, and it's just kind of harder to do anything with this data set we currently have. So last one is a violin plot. It's just show you how with these four columns, I want to see the distribution of the statistics for all the values. And the box plot, as I mentioned last time, is also a good way to show these values. It just shows the mean and the range and how that's spread around, etc. So again, we are not trying to make any conclusions, but it's just, you know, it gives us a good way to explore the data and the correlation and the relationship of all the data points we want to look at. So with that said, that's probably all for today. It's okay. It's about 8:30 now. So feel free to run this, and I'll probably need to update this treatment notebook. It hasn't been updated for a while. I haven't looked into those last several examples. I've really ran through all the whole treatment notebook until today. That's the first time I ran through the whole notebook until the last several lines. But next time, if you know, if I have time, I'll get back to the treatment notebook and fix those errors. And any questions?